There's three different major groups of fish that we'll study. The first type are called jawless fish. You know why they call them jawless fish?
They don't have a jaw.
They don't have a jaw. They can't open and close their mouths. Their mouths are stuck open. This is the first type of jawless fish. And there's a few types. The earliest fish were all jawless fish. This is an evolutionary tree of fish. And the earliest fish came about 500 million years ago in what we call the Cambrian period. And then they evolved into a whole bunch of different groups that we're going to study. But the jawless fish came first. Now the earliest jawless fish were armored fish. They were these fish that had armor plates all over them. And they couldn't close their mouths. They just stayed open. And they swam through the water, filter feeding. And they were well protected with their armored plates. And we called them ostracoderms. And they gave rise to this other group right here that was rather successful for a long period of time. They're called placoderms. Have y'all ever seen a chart like this? Know how to read it? The width of the bar tells you how many organisms, how many different types of species there were. So as you can see by the width of this bar for the placoderms, they started right about here in what we call the Silurian period, which is like 400 million years ago. And they get wider and wider, and there's more of them, and then see this end, so that means they went extinct. The cartilaginous fish, you can see, this is their evolutionary tree here. Cartilaginous fish include the sharks. And look how wide near the top here the ray fin fishes. That's like most fish that are in the sea. Look how wide that gets. That means there's a whole bunch of different kinds. This is usually the way evolution works. It goes from a few different types to many types, so it gets wider with time. And then we often see population crashes, usually due to some big disaster that happens. There was a big disaster at the end of the Cretaceous right here that killed a lot of organisms. There was a big disaster at the end of the Permian. You can see a lot of them died off there, got a lot thinner, thinned out the population. But the fish were able, some of the fish survived all that, and some of the fish went extinct. This group right here, the Spiny Sharks, went extinct at the end of the Carboniferous period. And the Placoderms went extinct too, but some of the jawless fish still survive. Most of them have been extinct, but there's a couple left. And this is one of them. It's called the Lamprey. Actually, this might be a hagfish. There's only two surviving types, the lamprey and the hagfish. Have you ever heard of these organisms?
I've heard of lamprey.
I think this is a hagfish.
Isn't the hagfish one that's a slime?
Yeah.
Yeah.
Slime's all over.
It says parts of a lamprey.
This is a lamprey? Okay. Yeah, they look similar. They both kind of look like eels. But but they're not eels. An eel is actually a fish, but is a bony fish. But this is a jawless fish. It's got an open mouth, and what many lampreys do is they suction on to some other fish and they suck its blood. They have these piercing mouth parts that can dig into the skin, and then they just suck blood.
Is that the thing that's underneath sharks?
No, that's different. That suctions under sharks, but it doesn't suck their blood. It just follows them around until they eat, and then
So
it
is it kind of
breaks
like a
off
leech?
of them. It's not a leech because it's not sucking their blood. Leeches suck blood, but these things are kind of like leeches.
Yeah, that's what.
Yeah. These things are kind of like leeches. You see, that's its mouth right there, and all those little things are teeth that will break the skin of the fish that they're sucked onto. These things have been known to attach and suck onto people before. And you get a big lamprey stuck on you and sucking your blood. It's no fun.
It's like a leech kind of.
It's like a leech.
Didn't I just?
I didn't hear.
I just see it.
Yeah.
I'm sorry.
You see it's got gill slits, just like chordates have here, and water comes into the mouth of this thing and comes out through those holes. That's how gills work. The water goes in through the mouth and out through the gill openings. Some kids think that water goes into the gill openings, but that's not right. That's water goes into the mouth, out through the gill openings, and oxygen is removed from the water. And these things filter feed too, so as the water comes out, any nutrients in there get trapped. There's some people holding a hagfish. See that thing?
Looks like a hair.
Hagfish have survived all this time because they have a unique method of defense. They squirt mucus out of their sides. When something tries to grab them, they release this chemical that reacts with water and produces this thick, sticky mucus. And whatever's chewing on them can't swallow them because this mucus fills up their mouth, and it can fill up their throat and actually kill them.
She looks grossed out.
Yeah, she's grossed out. Look, not only does it release mucus out of its side, it also releases blood out of its side. You can see their gloves are kind of bloody.
God.
So this bloody, mucusy hagfish, yeah, that's pretty nasty.
She's a pro.
You want to see hagfish video?
Yes. You like my job? She's a fish.
Gill clogging slime secretion in hagfish. There's not any sound to this. This is an underwater camera, and you can see this hagfish messing around down here. And the shark's going to try and eat him, I think.
Shark is going to go to choke.
And he's going to get a mouthful of mucus. It also tastes really bad.
I really didn't know fish could taste, to be honest. But I just ate them, guys.
Oh.
You right?
Yeah.
Tastes really bad and blocks his mouth, and that can kill the shark.
I might want to choke.
It can also clog up its
Arteries.
can clog up its gills.
Arteries.
Nah, bro.
Sounds like he is going to hurt me more.
Shut up.
165 video deployments have been achieved. 14 attempts to prey on hagfish have been observed. None successfully resulted in predation. What the hagfish will do is they'll crawl into dead fish and eat their insides up, suck out their insides.
They're scavengers.
They drop this thing to the bottom. It's got hagfish bait on it.
I really have some really nice ones.
Look like sea.
Two snakes.
The hagfish down there.
What's the thing trying to kill it?
I don't know.
Sea snake.
It's a snake. Knotting occurred. They could tie themselves in a knot and untie themselves.
What? I tried that.
And it's a way to remove the slime from their bodies. As they untie themselves, it pushes all the slime off. You see the little thing down there making a knot of itself.
Why is that useful?
It's a way for it to get all the mucus off of itself. It kind of knots itself, and then as it unknots, it pushes the mucus away.
Gotcha.
So it's just a special technique.
Ew.
There's the oral disc. This is a lamprey. Again, you could stick your finger right there, and it couldn't bite down on it. It doesn't have a jaw. It could suction, but it can't bite. Want to see lamprey video footage?
Yes.
In the depths of the Great Lakes is a scene reminiscent of a nightmare. Slimy, snake-like creatures with suction-cup mouths lined with rings of sharp teeth and a rasping tongue prey on the trout, salmon, and whitefish that live in these lakes. Sea lampreys are the vampires of the deep.
Here's a good lamprey mark on this whitefish.
The effects of one of the most notorious of the Great Lakes invaders dates back to the 1950s, when the lamprey virtually wiped out the commercial and recreational fisheries in the Great Lakes.
A fish is seldom able to free itself from a mouth like this.
Since 4 out of the 5 Great Lakes straddle the U.S. and Canadian border, both governments are fighting these silent invaders with every weapon they've got.
Our battle is constant, and we can't let up.
One of the most important weapons in this battle is lampricide, a chemical deadly to the lamprey, but non-toxic to humans, other mammals, and fish. They attack while the lamprey is still in its vulnerable larva stage.
Without question, this is the most important program to the Great Lakes. Without this program, we could not make progress towards lake trout restoration.
Lampricide is highly effective in small streams like this, but the mother lode of spawning lamprey come from the St. Mary's River. Here, a yellow granular chemical called balucide is planted in the riverbed below. It causes the lamprey larva to emerge from the mud, ingest a super concentration of the toxic chemical, and die.
Anytime we can reduce the number of lampreys, it's going to help all species of fish.
But even before the spawning season begins, thousands of captured adult lamprey await their fate. This is where the males will be sterilized, one by one, tail first. The lamprey is sucked into the heart of a robotic machine. A biologically active chemosterilant called Bizazir is injected into its belly.
If there's 100 sterilized males in the river and 100 normal males in the river, females in the river have a 50-50 chance of mating with a sterilized animal, and so in effect we will reduce reproduction in the river by 50%.
The sea lamprey has lived in the ocean for nearly 300 million years. It entered the Great Lakes through man-made shipping canals. Anglers and commercial fishermen have been severely affected by its invasion. This $7 billion a year industry is protected by the efforts of governmental bodies to the tune of $20 million a year. Canada spends $8 million a year fighting this pest. It's your concern and tax dollars that keep our Great Lakes protected. So stay informed and stay involved in this daily battle with the silent invaders.
Lampreys. Did you even know about that with lampreys?
I did not. They're them guys. Explode when they explode next day.
So that's your Jawless Fish, chapter 23. You've got 7 minutes. You can read it, the whole thing, and have no homework. You can stop filming if you want.